Bismillahirrahmanirrahim. Hello, my dear students. I hope you are all doing well. I welcome you all in class of Real Analysis by Robert G. Bartle. Lastly, we discussed the concept of epsilon neighborhood of a point. I hope you have watched that video. Inshallah, in today's lecture, we will discuss two questions related to epsilon neighborhood of a point available in exercise 2.2. These are question number 16 and 17. So, firstly, let us revise the definition of epsilon neighborhood of a point. If a is any real number, then and epsilon is any real positive real number, then the epsilon neighborhood of a is denoted by this notation, and it is actually the set of all real numbers. The epsilon neighborhood of a point is always a set. This is the set of all real numbers that satisfied the condition x minus a less than epsilon. Or in more simple words, this can be written as x belong to a minus epsilon to a plus epsilon. This is an open interval. So this open interval is actually represent the epsilon neighborhood of a. So now we discuss question number 16. This question number 16 says if epsilon and delta both are positive real number and a is any real number, show that the epsilon neighborhood of a and delta neighborhood of a, their intersection and their union are gamma neighborhood of a for appropriate value of gamma. Actually, what does this question say? This question says the intersection and the union of two epsilon neighborhood of neighborhood of a is always an other neighborhood. Actually, this result is can be derived from the metric spaces, and you can see this is also available in topology. In metric space or topology, you have seen the result intersection and union of two neighborhood of a point is again a neighborhood. So let us discuss this question for two cases. As here we have a two positive real number delta and epsilon. So in the first case, I will suppose that delta is less than epsilon. Then delta neighborhood of a is the set of all points such that the absolute of x minus a is less than delta. By using the inequality which says y absolute is less than b, and where b is a positive real number, this can be expanded as minus b less than y less than b. So by using this inequality here, this can be written as minus delta less than x minus a less than plus delta. By adding a on in each part, we have a minus delta less than x less than a plus delta. Say this is my inequality number 1. Now when x belong to the epsilon neighborhood of a, similarly as inequality number 1, we can obtain inequality number 2, but now radius is epsilon. So this is a minus epsilon less than x less than a plus epsilon. So this is inequality number 2 here. Now I have to compare the left hand side and right hand side of 1 and 2. So I will use here, as delta is less than epsilon and I want to find a minus delta. So multiply this inequality with minus 1, we have minus delta greater than minus epsilon. By adding a on both sides, we have a minus delta greater than a minus epsilon. Similarly, say this is inequality number 3. Similarly, when you add a on both sides of this inequality, the sign of inequality will not change, and this becomes a plus delta less than a plus epsilon. Say this is 4. Now combining 1, 2 with inequality 3 and 4. In inequality number 1, this inner part, this is inequality number 1. Now from 3, you can notice that a minus delta is greater than a minus epsilon. So you can write a minus epsilon less than a minus delta. And from inequality number 4, you can notice that a plus delta is less than a plus epsilon. So replace a plus delta less than a plus epsilon. So this shows that this open interval a minus delta to a plus delta is a subset of a minus epsilon to a plus epsilon. In other words, you can say that this open interval is actually definition of delta neighborhood of a. So we replace this interval with this notation, and this is actually definition of epsilon neighborhood of a. So x belong to delta neighborhood of a, subset of epsilon neighborhood of a. From set theory, we know that if a is a subset of b, then their intersection is equal to the smaller set, which is a here, and their union is equal to the larger set, that is b here. So applying this fact here this is the smaller set, that is the delta neighborhood of a is smaller and epsilon neighborhood of a is greater. So when you will take their intersection will be equal to a smaller set, that is delta neighborhood of a. Now I have to find a gamma. So as their intersection is a delta neighborhood of a, so in this case our delta will be equal to gamma. Similarly, when you take union of these two sets, this is equal to the larger set, and larger set is epsilon neighborhood of a. So their union will be the larger set. Again, if you set gamma epsilon is equal to gamma here, then this is equal to v gamma a. So in this case, you can notice that for the intersection, your gamma will be equal to the smaller number. Your smaller number was delta, and in case their intersection, your gamma will be equal to epsilon here. Now similarly, for the second case, if epsilon is less than delta, then same conclusion can be drawn just by changing the role of delta and epsilon. So there is no need to solve this case separately in detail. You can write just these lines. In case when your epsilon is less than delta, then their intersection will be equal to the neighborhood of a at a smaller number. What is smaller number? Smaller number is now epsilon here. And in case their union, this is equal to the neighborhood of a at larger number, that is delta here. And this completes the question number 16. Next, question number 17 is an important question, and this is very interesting. This question says that if a and b are real number and they are distinct, they are different numbers, then there exists epsilon neighborhood u of a and v of b such that their intersection is empty. This question says here u is a epsilon neighborhood of a and v is a epsilon neighborhood of b. We have to show that their intersection is empty for some epsilon. To prove this question, I will use contradiction. I will suppose their intersection is non-empty. It means there is some real number x that belong to their intersection, and at the end I will show that our supposition is wrong. And further, I will also show that this intersection is not always empty. there is some epsilon for which their intersection is non-empty. So let us start. It is given that a and b are real numbers and these numbers are different. Since a and b are distinct, so their difference will be non-zero. As you know, if we say a number is non-zero, then there are two possibilities: either it is greater than 0 or it is less than 0. But in both cases, its absolute will be positive. For example, if a is minus 5, then minus 5 is not equal to 0. Similarly, 5 is also not equal to 0. But in both cases, the absolute value of these two is always positive. So here a minus b is non-zero. It means its absolute value will be greater than 0. By dividing by dividing by 2 on both sides, this will become a minus b over 2, which is also positive. So I have to fix an epsilon, and epsilon is always a positive real number. So let us take epsilon is equal to a minus b absolute over 2. This number is equal to epsilon. Just a minute. Now I have chosen this number as epsilon, and consider the epsilon neighborhood of u. The epsilon neighborhood of u is the set of these real numbers that satisfy this inequality x minus a less than epsilon. Similarly, the epsilon neighborhood of v, which is the neighborhood of epsilon neighborhood v, which is the epsilon neighborhood of b, this will be the set of x minus b absolute less than epsilon. We will show that these two sets have an empty intersection. We suppose on the contrary that there is a real number x that belong to their intersection. So if x belong to their intersection, it means x belong to u and x belong to v. This is the common point of both sets. So when you say x belong to u, then it will satisfy this inequality because u is the epsilon neighborhood of a. So that's why x minus a absolute less than epsilon. Similarly, when you say x belong to v, this should be less than epsilon. X minus b less than epsilon. Absolute less than. So this inequality number 1 and 2. Now you have to consider this expression a minus b. By adding and subtracting the real number x, we have a minus x plus x minus b. This can be written as a minus x plus x minus b. By applying the triangle inequality, the triangle inequality says that this whole sum of absolute can be separated into two absolute. The absolute of first value a minus x and the absolute value of second x minus b. As a minus x and x minus a both have the same absolute value, so a minus x is less than epsilon. So replace a minus x with epsilon, and x minus b is also less than epsilon. So this becomes less than epsilon plus epsilon by using 1 and 2. This gives a minus b absolute less than 2 epsilon. But we have fixed that a minus b absolute over 2 is equal to epsilon. So from here, a minus b absolute is actually equal to 2 times epsilon. So a minus b is equal to 2 epsilon. This shows 2 epsilon is less than 2 epsilon, but this is not possible because this is not possible that a real number is less than by itself. For example, can you say 5 is less than 5? No, this is not true. So this is false. Hence our supposition is wrong. Hence u intersection v is empty. This is the important. This result is not true for every epsilon. The problem actually says there exists epsilon neighborhood, not for every epsilon. This problem says that at least one epsilon neighborhood exists, but this is not true for every epsilon. For example, we take let a is equal to 1 and b is equal to 2 and epsilon is equal to 0.5. Now if you find the epsilon neighborhood of a is 1 and epsilon is 0.5. The epsilon neighborhood of a is, this is the open interval a minus epsilon to a plus epsilon. This is the epsilon neighborhood of a. This is the u epsilon a. Now substituting the value of a and epsilon, my a is 1 and epsilon is 0.5. This become 1 minus 0.5. This is 1 plus 0.5. This is equal to 0.5 less than x less than 1.5. Similarly, if you find the epsilon neighborhood of b, this can be defined as b minus epsilon to b plus epsilon. What is b? My b is 2 and epsilon is 0.5. So this become 2 minus 0.5, 2 plus 0.5. This is equal to 1.5 and this is equal to 2.5. So the epsilon neighborhood of 2 is 1.5 to 2.5. If you draw these two intervals on a real line, you can notice that the first interval is 0.5 to 1.5 open interval. The second is 1.5 to 2.5. This is my set U and this is my set V. You can notice that there is a no portion that is common between U and V. So there is nothing to common between U and V. So for this example, intersection of U and V is empty. But if we take A is equal to 1 and B is equal to 1.5, now my B is 1.5 and the value of A and epsilon are same. Now in this case, the epsilon neighborhood of 1 is same, 0.5 less than x less than 1.5, but the epsilon neighborhood of b 1.5, substituting the value of b in this interval, my b is 1.5, my epsilon is 0.5, 1.5 plus epsilon 0.5. This become 1.5 minus 0.5, this is 1, and 1.5 plus 0.5, this is 2. So the epsilon neighborhood of 1.5 is open interval 1 to 2. Now if you draw these two intervals over the real line, the first interval is 0.5 to 1.5 and the second one is 1 to 2. This is 1 to 2. This is 1 to 2. This is your set U and this interval represent V. Now you can notice that there is a portion that is common between these two intervals. So now their intersection is 1 to 1.5, which is non-empty. So this statement shows, this statement does not hold for every epsilon. Actually this statement just says there exists epsilon. It means there exists at least one epsilon for which their intersection will be empty. But this statement does not say that this intersection will be empty for every epsilon, because you can find some epsilon for which their intersection is non-empty. So this is the concept of epsilon neighborhood that I discussed with the help of question number 16 and 17. And I hope now you have a clear understanding of this concept and these questions. Inshallah, in the next lecture, I will discuss question numbers 18 and 19. These are the two last questions of the exercise, and these two questions are related to minimum and maximum value of real number of the set. So if you find this lecture helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.